Perfect. We got on the floor, please. Agata, would you like to share your screen?
Yes, please. I will try now, and I hope everything will be fine. I hope you see it. Let's go. Super. So good afternoon, everyone. It's so pleasure to be here at CHASM conference and to present for you Analogue Astronaut Training Center. I will speak about mostly educational and scientific Analogue missions, because this is our main objective. Our main activity is to do science, but of course it is not so easy, you will see. So I represent, of course, Analogue Astronaut Training Center, but also I'm a leader of Life Science for Space Laboratory at the Space Technology Center, AGH HGH in Kraków. So we try to combine activities in these two sites. First, I would like to start from the history of Analogue Astronaut Training Center. We started an idea to have a simulator base in Poland in 2016 when me and my partner was working at European Space Agency. First time there, we met Bernard, who you saw today. And during this time, we initiated building, and we physically built with our hands modular analog research station, which then was moved to Piła and it became Lunares. There will be a presentation about Lunares, so you will hear more about this base. And now we focus completely on science and technology in our habitat. We try to simulate the spacecraft, because most of time astronauts spend inside the spacecraft in confined space. So we try to make all types of research considering long-term missions, meaning staying long in confined space with sensory deprivation. So this is the main thing, and this is how we educated, how we learned how to organize analog missions. So it was 4 years of gaining lessons learned, of trying to analyze all things that we want to do and all problems that we have. So until 2020, we managed to train 79 students. And of course, because we are scientists, we try to publish. We try also to support our students that they publish and that they can they can boost their space career. So in the last year, we already organized 13 student missions, and we start to be more and more professional. 70 students trained, and as you can see, we already obtained 9 master theses. So we transferred from publications, from just conference proceedings, because this is mostly the level of these publications, conference proceedings, we moved to a master thesis, and now we are finishing 2 PhD theses made only inside the habitat on analog astronauts. So this is very important that you can do it. So this is just the numbers, which we really like, because as you can see, we trained 58 Polish students, but much more students from other countries, 86 students. There is some mistake. But here you can see the distribution of different countries, and number means how many people represented each country. Also, what is very important for Analog Astronaut Center, we are employing people. So we are not only organizing analog missions, but we invite people who want to work in industry, in space industry. We are also applying for several technology grants, and we realize them. So all our grants, all our funding that we gain is for technology development, not for science, not for education. So all people who would like to work with us, we write together a grant application and we obtain money. And in this way, we already have 6 people working with us in several grants. So it is very good to know that you don't need only to participate in analog mission, but you can also make something more with this. Here you see also some graph showing that analog simulations became more and more, I would say, trendy among students. They see potential. Also, scientists can see more and more possibilities to develop, to create new R&D projects. And we are very happy about this. We see some growth, some really nice increase in these activities. And we see here student missions, but also other type of trainings that we organize. And what are these other type of trainings? First of all, as I mentioned, we develop new technologies. We develop prototypes of several useful tools, which may be later on somehow implemented in long-term missions. For example, we develop together with Professor Cameron from United States, we develop a pressurized spacesuit. So we are very proud of it, and we already collaborate with Project Possum. So we try to implement this technology, to apply this technology already now. Also, we teach our students how to create composite materials. So this is a really practical and useful time spent in Poland, where you create your own rocket. For example, here you can see very happy students. These rockets are reusable. Of course, it is very hard to transfer these rockets via aeroplane. They will be confiscated, but you can always travel with them by car. Also here we show that we organize stratospheric missions. So you can create your technology inside the habitat, for example, like a CANSAT, and later on, just after the mission, we can fly it to the near space environment. This photo, which is on my back, in my background, this is took from the mission that you see these happy students here. So also we try to teach students astrophotography. Our habitat is located in a beautiful landscape, very clean from electromagnetic pollution. So we can see all 5 clouds of Milky Way. This photo was taken by iPhone, so it is super not good. But I just wanted to show you that even using smartphone, you can see stars. And of course, very close to our habitat, we have astronomical observatory of Queen Jadwiga, where we can organize conferences. We can learn a lot about astronomy. Also, another additional training that we organize here in Poland is collaboration with how you name it, with Military Institute of Aviation Medicine in Warsaw, where they have the human centrifuge, one of the best one to simulate the rocket launch and the landing of astronauts. Of course, this is used mostly for pilots, but we also can provide you some simulation of rocket launch, these all pressures on chest, all G forces acting on the body. So you can try yourself here in Poland. Beside human centrifuge trainings, we also organize skydiving, and we are mostly specialized in diving, in neutral buoyancy experiments. For example, like this, we are now pushing very hard development of scientific diving. So we want to build new technologies that can be applied underwater and in neutral buoyancy, and then train our students also in this fantastic environment. Please remember that all real astronauts, they train a lot in neutral buoyancy environment. So we want also to specialize in this kind of trainings. But taking all together, we built Moon Mars community. So we are all focused on human space flight, on Moon and Mars colonization, maybe also utilizing resources out there. And of course, the most important collaboration is with Euromoon Mars. You heard today a presentation from Professor Bernard Foying. We, together with Bernard, with Euromoon Mars, with Ile, we organize MPOL program here in AITC. And here you see all missions that we already organized from 2020. And in 1 week, we organize MPOL 10. And then in April still we have another mission, MPOL 11, also co-organized with Euromoon Mars. Usually about 4 missions from Euromoon Mars we organize per year in AITC. Another new opportunity that is open now is contribution in Universe. It is a European Space University for Earth and Humanity. Maybe you heard about it. It is an alliance of several universities among Europe. And still, I know that there is possibility that companies and academia, universities, they can join. Even it is already more or less structured alliance, but still we can add some members. And AITC is a member of advisory board, so we are trying really to encourage students to gain practical courses in industry, in academia. We organize new courses, we write new courses. So my goal, my personal goal in the future is to gain ECTS points for participation in Analogue mission. And as I sit here, I can promise you that we will do this very soon. So Analogue missions will not only be some hands-on experience, some extraordinary adventure, it will be a pure educational and very high level internship that will be classified as a standard, as a part of your academic life. Also, because we started work together with Space Technology Center at AGH here in Krakow, now temporary, we don't have laboratory in AGH. I'm a leader of this laboratory, so temporary for all this year, the Life Science for Space Laboratory will be in AITC Habitat. So, the best part, I wanted to present you some of student projects in our habitat. The habitat is simple. You see a silver foil, which can be funny for you, but for us, especially for me and as a neuroscientist, it is very important to invite people to completely different environment comparing to what you see in your daily life. So this silver color, this all noise that is inside the habitat, it is completely unusual for your brains. And this is very important for us, that we want you and we request you to adapt to completely different conditions that you are adapted for. And in these conditions, you have 1 week to perform your experiments. So we have a minimum 2 months, 3 months of pre-training, which is a remote pre-training before the mission. And each person brings to the habitat its own experiment. And there is some condition. So this experiment must be publishable. Of course, we as a scientist, we decide we can support, supervise people to make their ideas useful for publishing. And in this way, we have several projects. I only show you a few. For example, we develop printable open access hydroponic systems. This will be presented on ISC in 2022, now in Paris in September. Hydroponic systems are also very important to do some passive systems, not involving electricity. We ran a very interesting experiment, which was the light projections displaying crew dynamics. So depending on crew emotions, the color inside the habitat is different. It was a great experiment. I really liked it. Also, as I mentioned to you before, we are making a lot of practical work. Even if you are not familiar with this, you need to train. And for example, here, astrophysicist, she is making astrobiological CANSAT design and assembly. So of course, we have a limited power consumption in the habitat, especially in this year. It will be simply a blackout if you use your daily limits. So we tried to develop this network, and some crews, some students, they want to support development of this habitat. So for example, they have much cheaper participation in the mission when they are making something for us. And for example, here you see that these two people are setting a third line, so-called, which is emergency line. So all sensors, all cameras are set on the emergency line, and other lines are like normal. Another project that we have is the reduction of carbon dioxide clouds using active and passive airflows. And here you can see some pipes, some ventilators. We provide to our analog astronauts several of them, and the main aim is to reduce levels of carbon dioxide inside the habitat. The habitat is designed in a way that if you are not safe, if you are not careful enough, you may have 6,000 ppm of carbon dioxide, which may be dangerous. So of course, we as a Mission Control Center, we immediately alarm the crew when there is something wrong, but the main task for crew is to keep these parameters in green color. Another experiment that we do inside the habitat is mapping human microbiomes. Here, of course, we travel to, for example, here to Arctic to bring some samples from Arctic, but also we are trying to map human microbiomes in different locations in the habitat, but this is kind of standard experiments. Most of habitats are doing this. What is unique is that we try to have very professional equipment for analysis of microorganisms for cellular growth. So we have all autoclaves, incubators, all sterile conditions to be able to run space biology studies. Very interesting also is some bioengineering, some using in situ resources. So for example, here these students, they had a competition to develop the low-cost functioning medical device using 3D printing and in situ resources. So basically they had to find everything what is inside the habitat and to develop stethoscopes, which are working. Very interesting topic, of course, is resources of water inside the spaceships, inside the space stations. So we try to elaborate ecological transformation of urine into drinkable water. We try to use as much power, as much cheap technology, as much passive as it is possible. So using several filters, we try to create new filtering methods using various types of physical parameters. Besides cleaning the water, we also want to optimize plant growth on various regolith simulants. We try to fertilize regolith simulant samples because we observe several problems with growth when the soil is sterile without bacteria. Most of plants are very susceptible for dying, and it is very common phenomenon occurring everywhere in space too. Effects of increased physical activity and sleep deprivation on aging. This was another typical from space medicine topic that was developed by University of Padua. And we are still waiting for results, but I hope that soon they will be also published. Another student was developing algae bioreactors and tried to compute how much we need to create such bioreactors, again using in situ resources. So bottles from water, drinkable water, were transformed into bioreactors, and how much this method can be efficient in CO2 scrubbing. You probably heard about this problem on ISS. CO2 is making some pillows that are very hard to remove. Also, what we really like to do, and we are very interested in development of new technologies, we see a big potential, is to play with microgravity simulators. Of course, it is hard to put a human body and to simulate microgravity on Earth, but for plants, for cellular cultures, for seeds, it is completely different scale. So we can rotate these cells, we can rotate plants, and we can simulate different gravity forces on them. So here you see one prototype. We have plenty of them, but of course, because this is a technology development, we are, from many reasons, we are not really allowed to show you because several technologies they will how to say, they will need to be patented, etc. So we are not allowed to show you now these works of our students, but I can tell you that these are very interesting machines developed in the habitat and tested there. Also, what we test is, for example, here you see friction, surface, and robots. So searching for optimal design of wheels, of floor, different types of composite materials which can be used in space. Inside the space station. This is all about space station. Another thing what should be useful and helpful for astronauts is to make them feeling well, make them healthy. And for example, for this, we test oscillations in various axes of the body using Vinci Power NAP. Sorry, it should be not MAP, but NAP. And for example, in this case, you see this material where people are lying down and swinging in different oscillations. And then we measure several parameters, physiological parameters, before, after, etc. Another project is a low-cost aquaponics system using in situ resources. Here, these engineers, they were asked to create something out of nothing, and that it should work and should be calibrated. And they did it in 7 days. So we were very proud of them. Another experiment is a virtual modulation of space architecture. I don't know if it is good or not, but this is fact that our habitat is using more and more artificial intelligence everywhere. I don't know if I'm not touching artificial intelligence and if some artificial intelligence is not analyzing some data. So we also try to implement some programs, some algorithms to modulate, to run illusions of space architecture, to make it bigger or more cozy. We use lamps. We have lamps that can be modulated. We have 3 types of spectra that can be used. So this is UVA, UVB. I know that UVA, UVB, but it is also very important for humans, this type of light, but only the concentration is limited. Then we have a visual spectra, and we have infrared light. So we can make a cocktails out of this visual and not visual spectra in order to obtain the best, the most healthy for the crew cocktail of light.
Agata?
Yes.
We're going slowly to the end. How many slides have you got left?
I just have the last one. This is just that we can also we also work with artists, so we build interactive museums. Here I told you about artificial intelligence. We feed artificial intelligence with several photos, and yes, and with that, with all this not only working but some joy too, I would like to thank you for your attention. And of course, we are very, very, very open for collaborations, especially that if we want to make science, we need to have comparable data, not only in our habitat, but in different types of habitats. So if you think that this may be interesting to run some comparable studies, please contact me. Thank you.
Thank you so much.
Thanks. Very nice overview. Bravo, Agata.
Thank you, Bernard.
Wonderful. So we're getting a bit tight on schedule, but has anyone got a quick question? Otherwise, we're going to switch to our last talk of the day. Agata, thank you so much for joining us today. It was really lovely. We will stay in touch anyway. Next time we'll have you on site, hopefully.
Yes, for sure, I will come.
And I'll stop the recording and send you the recording once it's uploaded too, so you can share it to the rest of your team. Thank you so much for joining us. You can stay on the Zoom call if you like to listen to the next talk. But really, again, a big round of applause. And I love what you do. It's great that you have so many projects involved and so much research. This is really important. So thank you.
Thank you also very much. Thank you.
So now we have the team from Roma representing. So you guys want to connect your PC? Yes. And the other computer was working. Mark has a magical computer. I think so. Yeah, that would be so much work.
Every day I'm with me as well.